Strength training is an important component of a fitness regimen. One way to build strength is to lift weights or exercise on machines that provide resistance when users pull, push, or lift. Typically, weights produce that resistance, but some machines use a completely different system. This exercise machine doesn't have the typical stack of weights. Instead, the handles are connected by a rope and pulley system to a pneumatic cylinder which creates resistance. This computer-guided laser cuts many of the parts out of sheet steel. It can make complex cuts which are accurate within 100 microns, the width of 2 human hairs. The parts go into a vibrating tumbler filled with ceramic stones and water. The stones rub against the parts, removing what's called scale, a flaky substance produced on the surface of the steel by the heat of the laser and oxygen in the air. A worker clamps the parts for the trainer's power module onto a welding fixture. The fixture is on a robotic cell. The cell rotates, delivering the parts to the robot, which proceeds to weld them together. Welding the power module takes 14 minutes. When the robot completes the welding, the cell returns the fixture to the worker, who inspects the module thoroughly, then transfers it to the finishing area. A worker grinds the welds flat. Then, with a finer grinding disc, smooths them out so that they won't show once the steel is painted. After washing the module in iron phosphate, a worker applies a positive electrical charge to the module and a negative one to the powder paint. Opposite charges attract, drawing the paint particles onto the surface in an even coat. Then the worker bakes the paint onto the steel in an oven. Elsewhere in the factory, another worker drills a 12-inch deep hole into a cylinder rod. The rod is steel, the piston on its end aluminum. He inserts the cylinder rod into the cylinder, also made of aluminum, then carefully inserts a sensor rod into the cylinder rod's hole. The sensor relays the cylinder's position to the machine's computer. Snap rings hold the parts together. After a paint job inspection, the trainer is ready for assembly. First comes the decals. The assembler wets the surface with soapy water, then applies them. Once the decals are partially dry, he gingerly removes the transfer tape and inspects for bubbles or gaps. Next, he installs the machine's computer. It calculates the power produced with each pull on the handles. Then he installs what's called the accumulator tank, which stores the air for the return stroke of the handles. He installs the cylinder. The bottom is assembled to a central pulley that connects to both handles. The top connects to the accumulator tank with an air hose. The amount of force is determined by how much air pressure the user lets in when pushing the yellow resistance control buttons. The buttons are attached to air hoses and wired to the computer. The assembler routes a 26-foot-long rope through the central pulley and through the machine's 12 additional pulleys. The configuration is designed to enable a wide range of exercises. After closing up the power module with a cover panel and installing the 2 height adjustable arms, the assembler installs a swiveling pulley on each arm and ties what's called a clevis to the end of each rope. The clevis holds a wide range of other attachments. Once assembly is complete, an inspector checks for any aesthetic or functional defects. He sets a resistance level, then pulls on the handles to make sure the cylinder sensor is reading correctly. Pulling a handle pushes the rod into the cylinder, forcing the piston against the incoming air pressure supplied by a compressor. Because this power trainer uses air rather than weights to produce resistance, users can work out at faster speeds, which produces higher power.